Geometry students, to the homework up video, page 552, numbers 1 through 20. Let's go ahead and get started. Alright, numbers 1 through 4, the directions say to find the perimeter of the polygon. We're going to find the perimeter. Now remember, perimeter means we're going to add up all of the lengths of the outside of the figure. Now, that's okay to do when you know all of the lengths. In this case here, we're missing this side right here. We do not know how long that side is, but notice we do have a right triangle, and we know two sides. So let's quickly use Pythagorean's theorem. There's your 2 legs squared equals hypotenuse squared, okay? 15 times 15 is 225. Now when you square this, guys, you square the 5, that's 25. And you square the 3, that's a 9, okay? Now, 25 times the square root of 9 is the same thing as 25 times 3, because the square root of 9 is really 3. So we end up with 225 plus 75 equals 8 squared. 225 plus 75 is 300. Take the square root of both sides, and your hypotenuse is the square root of 300. Now we can break 300 down into 100 times 3. The square root of 100 is 10. So we get 10 square root of 3. So students, what we really have here is 15 plus 10 square root of 3 plus 5 square root of 3. So bring down your 15, and then positive 10, positive 5 is positive 15 square root of 3, okay? You do not add the square root of 3, you just bring it down and put it with your 15. So that would be your answer. The perimeter is 15 plus 15 square root of 3. Alright, number 2. Now, we know all of the lengths of all the sides of this figure except this side right here, okay? Now, I know the length from here to here is 3, so I know the length from here to here is also 3. Same thing down here, the length from here to here is 3, okay? So what I'm missing is this gap right here in green. I don't know what this length is right here, okay? We'll call that X. But this gap from here to here is the same gap from here to here, okay? And we should be able to very quickly find this green line, okay? Off to the side, I'm going to draw this triangle, only bigger, okay? I'm going to put a 4 here, a 4 here, and a 60 here. Now students, would you please think about this for a second? It's really simple. If this is 60, think about it. See how this side here is congruent to this side here? We learned a long time ago when two sides of a triangle are congruent, their opposite angles have to be congruent. So this angle here has to be congruent to this angle here. So if this angle here is 60, then these two angles together have to be 120, because 120 plus 60 is 120 plus 60 is 180. So take 120 divided by 2, and you get 60. Now, a 60, 60, 60 triangle also has all 3 sides congruent. So if it's 60, 60, 60, then it's going to be 4, 4, and 4. So this length here is 4. So this length right here is 4. So this length right here is 4. Now, when you go to add up all the sides, understand you do not add this side here because there's really no side right there, okay? So we have 6 plus 3 plus 4 plus 4 plus 3. This would be 6, like this side, plus 6 plus 10. 3 plus 4 plus 3 is 10. So 6 plus 3 is 9, plus 4 is 13, plus 4 is 17, plus 3 is 20, plus 6 is 26, plus 10 is 36. So the whole perimeter would be 36. Alright, moving on to number 3. Now notice we have here it's looking like to me an isosceles triangle. But maybe it is, maybe it isn't. That's really irrelevant. All that I know is this. I'm missing two sides, the length of this side and the length of this side. However, students, I notice here that this side here is congruent to this side here. Okay? So, with that in mind, I can very easily and very quickly hopefully find this side over here. Now, the only thing I disagree with this problem on, and maybe I'm making a mistake, we really need to know that these two sides here are parallel, and they are. I don't know how else we would be able to prove that. And the reason you have to know that is we have to know that if from here to here is 6, then that means from here to here has to be 1.5. And this has to be 1.5 because if from here to here is 6, 1.5 plus 1.5 is 3 plus 6 is 9. This whole side here is 9. Now, the only way I can assume this is 1.5 right here is if I know that I have an isosceles trapezoid, but I'm just going to assume they made a mistake and did not tell me that, so I'm going to assume it's parallel and it's parallel. So I have a right triangle right here. I'm going to draw it off to the side over here for you. Right angle. This is 3 square root of 3 all over 2. And this is 1.5. Okay? Or I'm going to go ahead and use a fraction. Since this is a fraction, also 3 over 2. 1.5 is 1.5 or 3 over 2. So I'm missing the hypotenuse. So if I square one leg and I square the other leg, that equals hypotenuse squared. Now square this leg and you'll get 9/4 plus, now be careful, if you square this leg, you square this 3, that's 9, square the 3 here, that's square root of 9, square the 2, that's 4. Now, the square root of 9 is just 3, so really you have 9 times 3. 9 times 3, which is 27. So this whole numerator is 27, okay? So 9 plus 27 is 36 over 4 equals 8 squared. Now, students, if you take the square root of both sides, take the square root of this side, you'll get, well, the square root of 36 is 6. The square root of 4 is 2. And 6 over 2 is 3. So when you take the square root of this right here, you get 3. And the square root of 8 squared is h. So there's your hypotenuse. It's 3. That's really difficult to see. You might want to back up the video and watch that again to make sure you really understand that, okay? That can really be difficult. So this length here is 3. So this length here is 3. So 6 plus 3 is 9. Plus 9 is 18. Plus 3 is 21. So the entire perimeter is 21. Alright, moving on to number 4. Alright, now, if you'll notice, students, all of these triangles here are completely congruent. I mean, they really are. You have a right triangle with 9, 12. If this is 9, this is 9. You have a right triangle with 9, 12. If this is 12, this is 12 right here. You have a right triangle with 9, 12 and a right triangle with 9, 12. All 4 of these triangles, 1, 2, 3, 4, all 4 of these triangles are right triangles that have 2 legs of 9 and 12. So if you use Pythagorean's theorem, trust me, you will get 15 right here for this side, okay? So that means this side's 15. Well, this side would also be 15 because all of these triangles are the same. This side is 15. This side is 15. And so you're going to get 60 for your perimeter. 15 plus 15 plus 15 plus 15. Alright, number 5. Find the area of the polygon. Find the area. Okay. Well, okay, let's see what we're going to do here. I'm going to draw a line right here. So now what I'm trying to do is find the area of figure number 1, a triangle. Then find the area of figure number 2, a rectangle. rectangle's easy. The rectangle's very easy. It's an 8 by 5 rectangle, length times width. So the area of the rectangle is 40. Okay? Now, if this whole side here is 5 and this whole side is 10, then I know from here to here I must have a 5. So there's the height of my triangle. Now if this whole side here is 8 and from here to here is 4, then it's very obvious this red line right here has to be 4. So how do you find the area of a triangle? 1/2 times the base times the height. So the base is 4, the height is 5. Multiply all those together and you'll get 10. So the area of the rectangle is 40, the area of the triangle is 10, and so add those two together and your area is 50 square units. Alright, number 60, or number 6, excuse me. Now, notice that number 6 is a parallelogram, okay? Now, hopefully y'all remember how to find, will this work? No, it won't work. Okay, that's alright. We don't really care if the answer's in front of you guys or not. It's not really a big deal. Okay, I kind of flipped my parallelogram so you can see the base and the height. Remember, the formula for finding the area of a parallelogram is simply base times height. That's it. You need to memorize those and know those, students, okay? So with that in mind, I do know the base is 10. 2 plus 8. This whole length is 10. However, I do not know the height. The height is this dotted line right here. But students, I have a right triangle right here. Look at that. My hypotenuse is 8 and my leg is 2. So using Pythagorean's theorem, I can definitely find this length, we'll call it x. I can definitely find this height right here very quickly. So one leg is 2. My other leg is x. My hypotenuse is 8. So I would get x squared equals 60. Square root of both sides. And we get the square root of 60 for the base. So there we go. 10 times the square root of 60 is 10 square root of 60. Okay? Now, you know, really, to be honest with you, we can split this up. 60 is 4 times 15. And we know the square root of 4 is 2. So we put a 2 on the outside. 2 times 10 is 20. And we're left over with the square root of 15. Or you can type this whole thing into your calculator and get a decimal, whatever you prefer. But there's the answer. 20 square root of 15 square units. Alright, moving on to number 7. Now, would you please notice we have a quadrilateral. 1, 2, 3, 4 sides, quadrilateral. And notice the diagonals are perpendicular. Well, remember, anytime you have a convex quadrilateral in which the diagonals are perpendicular, the area is 1/2 times one diagonal times the other diagonal. Okay, so we know this is 6 right here with a slash through it. So we know this line over here with the same slash must be 6 also, okay? There we go. Now, we know from here to here is 12. However, we don't know what this length is right here. But hold it, maybe we can find that very quickly because we do have a right triangle right here. See that right triangle? 6 and 8. We're missing a leg right here. We'll call it x. So one leg is 6. The other leg is x. The hypotenuse is 8. Next I would have, let's see, 64 minus 36 would be 28. So if you simplify, you'll get 28. So take the square root of both sides, and we're left with the square root of 28. Alright? So that would be this right here. So you really have 12. I'm going to go ahead and make that decimal. I think it'd be a lot easier. So 5.3. So this red squiggly line right here is 5.3. So are you ready? How do you find the area of this quadrilateral? So this whole diagonal is 12. The other diagonal is 17.3. 17.3 because you have 12 from here to here's 12. From here to here's 5.3. So 12 plus 5.3 is 17.3. So I have 1/2 times 12 times 17.3. And we end up with 103.8 square units. 103.8 square units, which I know is clear right here on the screen. What it says is 72 plus 12 square root of 7. If you type that into your calculator and hit enter, you would get, whatever I just said a second ago, 103.8 square units for the area. Alright, number 8. Alright, let's find the area of this trapezoid. Now this is a trapezoid, okay? A trapezoid is when you have a quadrilateral in which you have exactly two parallel sides, which is what we have. So there's my trapezoid. Okay, so this would be 5. This would be 8. And this would be 3. Now, remember, students, we have learned how to find the area of a trapezoid. It's 1/2 times the height times the two bases added together. Now, we know, and you know what, students, I apologize. I don't know why I turned this thing. I don't think there's any need to turn it at all because you want your parallel sides running horizontally, so that's my fault. We're going to use this over here. We know one base is 5 and one base is 3. The bases of a trapezoid are always the parallel sides. So I know one base is 3 and the other base is 5. So 3 plus 5 and 1/2 is 1/2. The only thing I'm missing is the height. Well, the height is this length right here, okay? Which will be the same as this length right here if I drew an imaginary line here. Now, why would I draw an imaginary line there? Because that gives me a right triangle right here. And I know if this whole side is 5 and this much is 3, then I know this little segment right here has to be 2. And now I know the hypotenuse is 8. So I can very quickly find this height right here. So I'm going to say that I have one leg is 2. The other leg I don't know. My hypotenuse is 8. So I'm left with leg squared equals 60. Take the square root of both sides. I'm skipping a lot of steps on these now, guys. We've done so many Pythagorean's theorems, okay? So there's your height, square root of 60. Alright, so we have 1/2 times the square root of 60 times 8. Now remember, when you're multiplying all these numbers together, you can go in any order that you want. So let's take 1/2 times 8. 1/2 times 8 is 4. So now you have 4 square root of 60. 1/2 times 8 gives you 4. And now we can break down 60 into 15 times 4. The square root of 4 is 2. Cross off the 4, put a 2 on the outside, and we should get 8 square root of 15 for the square units for the total area. That's a pretty tough problem, so you might want to back it up and watch it again if you're confused at all, okay? There are plenty of negatives to a video class, but there are also positives, and one of the positives is you can look it up if you need to and watch it again, okay? Or back it up and watch it again. Alright, numbers 9 through 14, we're going to match up the formula with what it goes to. So first of all, perimeter of a square. Well, think about it, guys. Perimeter of a square. You have side, all the sides are the same. So it's really S plus S plus S plus S. Or just 4 times S. So there we go. Letter E would be the perimeter of a square. Letter E. Alright. Alright, moving on to area of a rhombus. Well, guys, a rhombus is a four-sided figure that always has perpendicular diagonals, always. So if it has perpendicular diagonals, then it's 1/2 d1 times d2. Letter D. Area of a triangle, that's 1/2 times base times height. Letter A. Now, this is a really weird formula. I'm not so sure we went over this, although I'm sure we could prove it. But process of elimination, this is the only perimeter that we have left. Perimeter, so it has to be letter B. Alright, let's take a look at number 13. Number 13, area of a parallelogram. Well, area of a parallelogram is just base times height. Letter F, we just talked about that. Area of a trapezoid, we just talked about that. 1/2 times the height times the sum of the two bases, so letter C. Alright, pretty simple. Moving on to 15 through 20 now. They want us to estimate the number of flowers needed to cover each portion of a float. Okay, so first of all, for number 15, they want to know how many roses are needed to cover a 4-foot by 4-foot square. Now, if you'll notice in the directions, all of your flowers are in square inches. Okay, so we're going to find all of our areas in inches. Okay, so 4 feet is really 48 inches. 4 feet is really 48 inches. So what's the area of a 48 by 48 inch square? Well, 48 times 48 is 2,304. So the area of the square is 2,304 square inches. Now, they want to know how many rows it'll take to fill up this square. Well, 1 rose is 7 inches squared. So 1 rose is 7 square inches. So let's see how many times 7 goes into this number, and then you'll know how many roses that you need, okay? 1 rose is 7 square inches. We have 2,304 square inches. Let's see how many times 7 goes into this very quickly. 21, 20, that's 2, 64. That would be 9. So about 329 to 330, approximately 329 roses. That's really practical math, okay? You would need to know that in order to know how many roses to buy to fill up this portion of the float, okay? Number 16. Remember, everything is in square inches when it comes to your flowers. So we're going to say we have 48 inches by 72 inches, okay? So 48 times, it's a rectangle, so length times width would give us 3,456 square inches, alright? Now 1 daisy, if you look in the directions you'll see this. 1 daisy is 5 square inches. So I've got this many square inches. Let's see how many times 5 will go into this. 691. So approximately 691. Approximately, okay? Alright, number 17. Or we have a parallelogram. How do you find the area of a parallelogram? Base times the height. So the base is 60 inches. The height is 36 inches. So base times height, 60 times 36 is 2,160 square inches. Okay. Now, how many tulips will fit in this area? Well, 1 tulip, if you look at your direction, one tulip equals 4 square inches. So how many times does 4 go into this many square inches? Well, let's see. 540 exactly. So the answer is 540. You can see that right up there. Well, it's kind of cut off, but 540. Alright, number 18, we have a trapezoid, okay? Remember, the area of a trapezoid is 1/2 times the height, then add the two bases together. Now, your base here would be 96 inches. Your base here would be 72 inches. And your height here would be 36 inches, okay? So we have 1/2 times 36 times, add your two bases together, you'll get 168. So let's multiply all these numbers together, and you will get 3,024. That would be your square inches. Alright, now, roses, of course. One rose is 7 square inches. One rose equals 7 square inches. So how many 7 square inches will go to 3,024? Well, let's see. 28, 22, 14, 432 exactly. So the answer is 432. Alright, number 19. We have a triangle. And how do you find the area of a triangle? Well, it's going to be 1/2 base times height. Well, 10 feet would be 120 inches. 12 feet would be 144 inches. So I really have 1/2 times 120 times 144. Alright, so if you multiply these three numbers together, you will get 8,640 square inches. Okay, now one carnation equals 6 square inches. Alright, so let's see how many 6 square inches go in 8,640 square inches. 26, 424. Actually, 1,440 exactly. Alright, so there we go. Number 20. Alright, we have a rhombus. Now remember, the area of a rhombus is 1/2 times the two diagonals. So 2 feet would be 24 inches. 3 feet would be 36 inches. So I really have 1/2 times 24 times 36. Okay? Well, if we multiply those three numbers together, we're going to get 432. Now, a daisy, one daisy is 5 square inches. So 1 daisy is 5 square inches. So let's see how many 5 square inches go into 432. It would be what? About 86, approximately 86, okay? And that's it, guys. I hope this mid-chapter review and this homework help video has been a help to you. If you have any questions, don't hesitate